this is Charlie Bullock and this is my CT5009 Game Engine programming tutorial. In this lesson we're going to go over creating a waypoint based AI navigator for Unity and then further expand this by adding in states for these AI for a tree based system, state based system. To cover in more detail what and how we are going to do this, I prepared a quick few slides for us to go over what we shall be doing in this video. In this tutorial we'll be creating what is known as a weak AI. This also has other names like applied AI too. Basically this means an AI that does a specific given task, and in our case that specific task is AI in Unity navigating between waypoints and reacting to the player and environment. This is in contrast to what is known as a general AI, which is an AI which can do multiple things without being specified for it. These are two very different things, so this AI will wander around our environment, grow when entering certain areas of the environment, run away or charge at a player, sometimes rest between waypoints and sometimes grow quicker. To do this, we will be using a template project which I've prepared for us to get us started. And this has set the nav mesh baking up for us, which is built into Unity and we will be utilising for this tutorial. From this template we're going to add scripts to all the preset waypoints in the map, which will sort them into a nice array via their tags for us, which we can then utilise in our second script, which will probably be called our Hippo AI. Then after the Hippo AI to wander between the different waypoints correctly, we will add in the collision growth, player encounter, fleeing and charging, etc. And finally, we will go through assigning slightly random values for important things like the speed of our wandering AI hippos. As mentioned a bit in the last slide, we're first going to make the waypoint scripts. Then the Hippo AI script for navigating between the different waypoints in the game. Then use an enum to manage between the different Hippo states, because our Hippo AI will be state based as mentioned before. Then adding in food and player encounter reactions, then randomly generating the values for things such as speed, and finally, hopefully if you followed along correctly, you should have a working AI navigation which you can in theory repurpose for your own use, for example for patrols. So this is the template project which you will start with. Here the scripts for the player are already set up, as well as the waypoint tracker and Hippo AI scripts are already added to the relevant objects. However, they contain empty methods. This is what we're going to start with. Right, so here we are inside the waypoint tracker script, and essentially what we have for variables are a list variable for storing the waypoint connections and a radius float variable which will define the sphere radius for each waypoint when checking their connection to other waypoints. In this start method we're going to create an array which we need to create an array of game objects to store the waypoints with Hungry Hippo waypoint tagging. We're also making the waypoint connections a list of this script on waypoints. Then in the start method we will loop through the amount of waypoints in the all waypoints array and ensure that as long as a waypoint is not null and the radius between this waypoint and the next waypoint is not null, then we add this next waypoint in our loop to the waypoint connections list. Then in this onDrawGizmos method, all we are doing is drawing a wire sphere in the scene around each waypoint so we can see if they connect with the other waypoints correctly. This is simply done by us giving the draw wire sphere gizmo the position of our waypoint in script and the sphere radius mentioned before. Now our final method in this class is for our next waypoint, which will do some if-else statements to firstly check if there are no waypoint connections, and in which case we want to return null. Then it will do an else if check to see if waypoint connections is no more than 1, and if so it will return the previous waypoint as it would be the only one, and else it will set the iNext index to 0 before assigning it a random value from the amount of waypoint connections which will then become and be returned as the next waypoint. If you need, feel free to pause the video at any time to read through and type the code at your speed. So here we are in the Hippo AI script, which will be utilising the waypoint tracker for waypoint navigation. Upon clicking the cross to the left of line 20 on the variable region, a large drop-down of variables used will appear. Additionally, you will see current waypoint and previous waypoint variables which use waypoint tracker script. And below this, an enum as well as its reference, which we're going to use later on. We're going to start off by adding the basic patrol into this here script. Then, after, we will add in the state, then environment collision, and then, finally, random values for our AI hippos. For now, we're going to begin in the start method by starting, and in it, we will go to our wait score routine, which we're going to make have a delay of a second. In this IEnumerator wait method, we're returning that 1 second wait delay before adding an navmesh agent to the hippos which have this script attached. This navmesh agent is what will allow our hippos to navigate on our bait navmesh area. If the hippo still doesn't have a navmesh agent, which it will have, we will check and destroy the game object. Else if it does, and there is nothing in current waypoint variable mentioned before then, we'll simply make an array of game objects called all waypoints and add all the waypoints that have the hungry hippo waypoint tag on them into this array. Now all being well, that array is going to be more than 0 since we have added in our many waypoints into it. Then, while our current waypoint is still null, we're going to assign a random waypoint to our starting point variable, which was also mentioned before. And as long as that isn't null, we will assign our starting waypoint to our current waypoint. To simplify, we're giving our hippo a waypoint which is going to go to. The randomness is to simply make its navigation unpredictable. Finally, the last thing we shall do is invoke our setDestination method after a second, which, as you would presume, will be our method to set our Hippo AI navigation destination. Also remember, while we're using our wandering hippos in this example, this can easily be changed and repurposed to whatever you would need. Now in this setDestination method, we're starting by checking our current waypoint is not null. As long as it is not, then we first try to set the current vector to the next waypoint, and if not, we set the play's destination to the target vector. The reason for this is for when the hippos will flee the player for the corner. If we run this now, and you have followed along correctly, your project should be working like this. Next we're going to add states using this enum we're calling Hippo States. We will be able to switch between the different states of our hippos. When it will be wandering, we're going to want our hippos to go between the points as normal. When it will be running, we're basically going to want our hippos not to wait between changing waypoints. When our hippos reach low health, they will go into the charging state and charge towards the player. When retreating, our hippos will run to the corner location we have defined as hiding points. If the state is resting, then our hippos shall just rest when reaching the next waypoint. Now in our update function, we're going to do all the checking we're going to need. So first of all, we have an if statement ensuring our navmesh agent is set to the value of the iHippo speed variable, as long as it is not null in general. Below this we have a large if statement. The first part is to check if our hippo has no health, and if so, we'll just destroy it. Then if our hippo has really low health here, it will go into a rapid charging towards the player, so we're just setting the hippo state as charging and cranking the hippo speed to 100. Then if the hippo is within 10 meters of the player, we're simply increasing hippo speed up to 20, and setting the state to retreating from the player. If the hippo is over 10 meters away from the player, then we're going to set the hippo to wandering. If the hippo has over 10 health but less than 30, then we set the hippo speed to 10 and hippo state to running. If the hippo has over 100 health, then our hippo is just going to be resting. Then at the end of this method, we're just calling the Hippo Waypoint States method. So in this Hippo Waypoint States method, we have got a switch statement set up for the different hippo states. And this really is what organizes what our hippos will do for the different states. So our first case is for the charging state, and all we're doing here is setting the destination for our Hippo NavMesh agent to the player itself. Our next case is for our retreating case, and here we assign our destination again as the previous state, but we have set the destination to being our hiding point, which is just a pre-chosen vector 3 in the corner of the map for our hippos to flee to. Then you may notice our next three cases for wandering, resting and running do not actually have a break between them, and that is because they will all be waypoints patrolling, but rather the only differences are that when running our hippos will not wait, and when resting our hippos will remain in the same point. Now all we have left is we're going to add setting our hippo state to wandering in this else statement in our set destination method. Now if we just test, it should still work perfectly fine. Next we're going to make our hippos grow when reaching our food and water source and shrink and lose health when hitting the player. Here in our onTriggerEnter method, we're just basically checking if colliding with something tagged with the player or consumable, and then changing our values such as health dependent on that. You can also notice if B is hungry is true, the hippo will grow at a rate 10 times more when colliding with a consumable than if not. Finally, in our start method, we're adding in randomly generating values for our hippos, as you can see here at the start, to add a level of uniqueness. Now we're going to play this, and you can use WASD to navigate, R to restart and escape to quit. So as long as you followed along to this tutorial correctly, you should see your Hippo AIs freely moving between waypoints, and upon proximity of the player they should flee to the map corner. They should also grow upon reaching food or water zones and shrink upon direct collision with the player. To conclude, if you've completed this correctly, you should be able to use this as a spring-off point in your own projects in future or for AI navigation via waypoints, for example for patrolling guards in a project. If you have encountered any errors or problems, feel free to go back or pause this video at any time to double check you have followed the guide and explanation correctly. Additionally, please ensure you're using Unity 2018.1.9 F2 or compatible version. Many thanks, and I hope you've enjoyed.